Okay, we can also use valence bond theory and orbital hybridization to explain bond lengths. Generally, if you have hybrid orbitals that have a greater p character, they tend to stretch further out from the nucleus, and that would lead to a longer bond length. So, for example, if you have a carbon sp2 hybrid, okay, it's going to stretch out farther than an sp hybrid, and an sp3 hybrid is going to stretch out further away from your carbon atom. So that could lead to longer bonds. If you have to compare two cases where in one case carbon uses sp3 for bonding and in another case it's using sp2, you would expect the bond involving sp3 to be longer, provided the other side is the same. Okay, the other side of the bond is the same. So here's an example. Let's compare C2, this is ethane right here, and ethane, and this is ethylene or ethene. And the difference between these two is that this is a single bond here and this is a double bond. So this is CH3, the bond, and this is CH2, double bond, CH2. Okay? So how do we explain the differences in the bond lengths here? What do you notice about this single carbon-carbon single bond? It says here that the bond length is 153.1 picometers, whereas over here for the double bond, carbon-carbon double bond, your bond length is 133.9. So the carbon-carbon double bond is shorter than the carbon-carbon single bond. Why is that? Well, can explain that using the notion of hybridization by saying that, okay, this carbon right here, this is 1, has a steric number of 4, right? So it's 1, 2, 3, 4 groups sticking out of it. So this carbon here is an sp3, and this carbon is also sp3, using sp3 for signal bonding. So you're looking at an sp3 to sp3 overlap in ethane, okay? Whereas in ethylene, your overlap is sp2. This carbon has 1, 2, 3 groups sticking out of it. So this is an sp2, and this carbon also has 3 groups sticking out of it. So that's an sp2 to sp2 overlap. And so we said this sp3 orbital, this sp3 hybrid has greater p character. So the electron density around that carbon is going to stretch out farther away than the electron density around this carbon in an sp2 hybrid. So you expect this single bond to be longer than the double bond. Now let's compare the carbon to hydrogen bonds. If you look at the bond between carbon and hydrogen, all right, this bond right here is 109.4 picometers. Carbon to hydrogen, but this carbon to hydrogen is 108, and again this length right here is shorter. How do we explain that? Okay, so hydrogen to carbon bond here is S to sp3 overlap, whereas the hydrogen to carbon bond here is an S to sp2 overlap. And again, because the carbon here on the right is using hybrid orbital with lower p character, less p character, sp2, we expect that bond to be shorter. Let's